Okay, in this video we're going to talk about and introduce the idea of solving trig equations. Before we jump into our trig equation examples, it's important to understand the general idea of what we're doing. Back when we were solving simple quadratics like this, what we would do is we would simply move that 9 over, take the square root of each side, and we would get a plus or minus 3. What we understood is that logically this answer made sense, not only algebraically, but we understood it graphically as well, because what our solutions meant was that graphically x squared minus 9 was our parabola that was shifted down, and we knew that it crossed the x-axis at a positive 3 and a negative 3. So when we were solving this equation, we were finding where did our parabola cross the x-axis, and we knew it crossed in two locations. Now when we're solving our trig equations, what we need to understand is that our trig functions are periodic, they're cyclical, they go on forever. So there are an infinite number of places where our graph could cross the x-axis or ultimately could equal a particular value, as we'll ultimately see. And what we need to understand is that we are going to specifically restrict our answers most often from 0 to 2 pi, so that we don't have to continue writing everything over and over. When we're in class, we'll also learn how to write answers in a general form to describe all of the potential answers that could be found. So all we're going to look at today is how to find where it maybe equals 0 or maybe where it equals a particular value and solve those equations. So it is good to have a graphical idea in your head as well. So now, if we look at the foldable that you have, we can jump into this top window here, and as the outside says and the inside also says, these equations should both be of what we would see as a linear format. The highest exponent is a 1. So similar to what you would have solved in the past, we can just solve for this secant theta, dividing both sides by our 2, of course, and we get a negative 2. So once your trig function has been isolated, what you can then picture in your head is where would the secant values potentially be negative. So we have all students take calculus, secant being the reciprocal of cosine. So what I know is that I potentially have angles for theta that could be in this quadrant and in this quadrant. So what I'm looking for particularly is what angle measure would give me a secant value of negative 2. Well, I know that secant equals a positive 2 in my first quadrant when my reference angle is 60 degrees. So my 60-degree reference angle in the second quadrant is actually 2 pi over 3. And my 60-degree reference angle in the third quadrant is 4 pi over 3. So we can simply say theta equals 2 pi over 3 and 4 pi over 3. Moving over here, similar idea, we just need to isolate the trig function. So I'm going to get tangent theta equals a negative radical 3 over 3. I skipped some steps. I just subtracted my square root of 3 and then divided by 3. So now I'm looking for what quadrants would my tangent value be negative. And I know tangent's going to be negative in this quadrant, What reference angle is going to give me a tangent value of a radical 3 over 3? And I know that that reference angle is going to be 30 degrees. So my answers for theta would be the 30-degree reference angle in the second quadrant. I know that's 5 pi over 6. And the 30-degree reference angle in the fourth quadrant is 11 pi over 6. Okay, so moving on to our next idea, we're going to look at, every once in a while, you'll have a problem that's in a factored form. So I have different trig functions, but they've factored this out for me and set it equal to 0, so that's nice and easy. So all I need to do is use my zero product property to identify the fact that sine theta would equal a negative 1, setting that factor equal to 0, and tangent theta is equal to 1. So, similar to what I did now on the previous problem, the trig function has already been isolated. I simply need to know where is my sine value, what angle can I evaluate sine for that I get a -1? Well, I know that that's down here. I'm thinking on a 0 to 2 pi interval, so this theta value would be 3 pi over 2. So that's one of my answers. For tangent theta, this time my tangent is positive. So in what quadrants is tangent positive? Here and here. What reference angle is going to give me a tangent value of 1, and that's going to be 45 degrees. So my reference angles of 45 degrees in these two quadrants will give me a theta value of pi over 4 and 5 pi over 4. So this problem has actually 3 values of theta that would give me a true answer. The last one that we're going to look at today is factored forms, and we're going to introduce an idea of a substituting for a different variable that some students find useful. So I'm asked to find 3 cosecant squared minus 4 equals 0. So first thing I'm going to do is I'm going to isolate my cosecant squared. So I get cosecant squared theta equals 4 over 3. I'm going to take my square root of each side, remembering that we have to take the square root of the top and the bottom. On the left-hand side, the square root is going to cancel out my exponent. On the right-hand side, I can't forget that the square root gives me a positive and a negative. So I get 2 over the square root of 3. So now I'm looking for both positive and negative values for cosecant. So when I'm thinking about all students take calculus, I know that cosecant's the reciprocal of sine, and it would be positive in these two quadrants, but it would be negative in these two quadrants, which means I actually want to pull my reference angle and identify it from every single quadrant here. So I need to know what reference angle would give me a cosecant value of 2 over radical 3. Now you may be thinking in your head that you need to rationalize that, and you certainly can do that and picture it in your head of 2 radical 3 over 3. But either way, the theta value that's going to give me, or reference angle that's going to give me a 2 radical 3 over 3 is, for reciprocal of sine, will be our 60-degree angle. So what we want to know is, what are the 60-degree reference angles in all 4 quadrants? So theta will be pi over 3 from the first quadrant, 2 pi over 3 from the second quadrant, 4 pi over 3 from the third, and 5 pi over 3 from the last. On my last example here, instead of having a simple problem where I could solve by square roots, I actually need to factor. Now some students struggle with the factoring on these, so what you can do, since I can see that I have a cosine squared and another cosine, I can rewrite this in terms of a different variable. This isn't a requirement, but it does make the problems a little bit simpler for students to follow. So if I rewrite this problem, I'll have 2y squared minus 5y, just substituting the cosines for y, plus 2 equals 0. Now we're down to a trig function or a quadratic that you can simply factor mentally. These will always factor in a really simple fashion. So I have 2y and y. I know that I'm going to need a 2 here and a 1 here. I know they both need to be negative. So using my zero product property, I get y equals 1/2 and y equals 2. Back substituting, because I wasn't asked to solve for y, I get cosine theta equals 1/2, and cosine theta equals 2. Now what I immediately recognize is that cosine theta of 2 doesn't make any sense because 2 is not in the range for cosine. Cosine reaches a maximum value of 1 and a minimum value of -1, so this cosine theta of 2 doesn't make any sense. It's an extraneous solution, so we can just reject that one. So we can come back here, just continue repeating what we've done on the previous problems. All students take calculus. I'm looking for where cosine's positive, here and here. What reference angle is going to give me a cosine value of 1/2? That's going to be 60 degrees. So my answers for theta are going to be pi over 3 and 5 pi over 3. And that's all that we're going to do for our basic trig solving for today.